Let's review average velocity. We know the average velocity is the slope of the secant line on a position time graph. So here we have a position time graph. So a secant line would be a line between 2 points. So this is a secant line. So if we wanted to find the average velocity between time equals 2 and time equals 3 seconds, we would be finding the slope of this line right here. All right, so remember that to find the slope of a line, it's the change in y over the change in x. In this case, our y is position, so we have the change in position over the change in time. So our time, we can either go 2 to 3 seconds or 3 minus 2, either way, but remember that whichever our y and our x have to match up top and bottom. So if we did 2 first, we'd have 2 seconds, let me put the units in here, minus 3 seconds. And since we did 2 first, we have to do f of 2 first, right here, which looks like it's about 2 meters. And at 3 seconds, we're at 0 meters. So 2 minus 0 gives me 2 meters up top, and 2 minus 3 gives me -1 seconds on bottom. So my average velocity between 2 seconds and 3 seconds is -2 meters per second. So this makes sense because our units that we got are meters per second, which you should recognize as units for velocity. So that's good. And then let's talk about why this is negative. Why are we negative? All right, so let's say that this is our position and we have a car, and our car is traveling east first. And so this is my 0 position that I started right there. And so at 1 second, I was, let's see, about there. So I was about 4 meters away. And then once I got up here, you see that our position starts getting closer and closer to 0. So our position is going this way again. So we're traveling west, right? So between 0 seconds and maybe like 1.1 seconds, we have positive slope, so positive velocity, and we're traveling east. And then from about 1.1 second to 3 seconds, we have negative slope, so we're traveling back west. And then from 3 seconds up to about 4 seconds, we have positive slope, so we started traveling back east again. Let's say instead of just having the graph, we were given a formula here for the position function, and we are still trying to find our average velocity between time equals 2 seconds to time equals 3 seconds. So how could we do that with the formula? Well, we need to know our change in position over change in time. So we know that our time is 2 seconds minus 3 seconds. But we need to know the position at time 2. And we need to know our position at time 3. So we need to find S of 2 and S of 3. So to find S of 2, we come back up here, and everywhere we see a t, we put in 2. So we have 2 cubed minus 6 times 2 squared plus 9 times 2. And we'll get 2, and this is position, and remember our position is in meters. position is in meters. And then we need S of 3. So again, everywhere we saw a t, we're going to put in 3. So 3 cubed minus 6 times 3 squared plus 9 times 3. And that's going to give us 0 meters. So let's see, we had S of 2 is 2 meters. So 2. S of 3 is 0 meters. So 2 meters minus 0 meters over 2 seconds minus 3 seconds. And again, we'll see that we get negative 2 over 1. So we get negative 2 meters per second.